Hello everyone, welcome to the Intelligent Oil and Gas Forum of this year's Huawei Industrial Digital Transformation Conference, with the theme of driving data to barrel, building fully connected, intelligent oil and gas. Having been affected by the continuing pandemic, the recovery of global economies, and many other factors, digital transformation has become a must for oil and gas companies to develop in the future. During the process of digital transformation, data is at the core. How can oil and gas companies focus on data, enable data to generate more reserves and production, and fully explore data to increase business value? Now let's move on to how Huawei Next Generation Storage for HPC advances oil and gas exploration, which is from Lai Nenghe, Chief Professor from the Geophysical Research Institute, BGP, China National Petroleum Corporation. Welcome, Mr. Lai.
Hello everyone. Today I'll be discussing Huawei Next Gen Storage for HPC advances oil and gas exploration. I'm from BGP, China National Petroleum Corporation. BGP is a multinational geophysical solutions provider specializing in seismic exploration in the oil and gas industry. The company's operations cover seismic acquisition, data processing and interpretation, equipment manufacturing, and software development. I've been with the company for over 38 years and personally been involved in HPC data processing, software development, AI informatization, and data center infrastructure. Today, my presentation shall consist of 3 parts: new challenges in oil and gas exploration, Huawei's solutions for coping with these challenges, and best practices. The oil industry chain is divided into 3 parts: upstream, refining and chemical processing, and sales. Throughout the entire chain, oil and gas seismic exploration is found in the most upstream section, playing a crucial role and adopting many advanced technologies. What is oil and gas exploration? It's a series of activities related to geological surveys and geophysics that are performed to identify oil or gas exploration areas and reserves. The exploration involves 3 main phases. First, acquisition. During this phase, seismic waves are manually created and underground signals are returned to generate field data. Second, processing. HPC systems are used to turn the acquired signals into data volumes that indicate underground tectonic features. Third, interpretation. Experts analyze and study the data volumes to locate oil and gas accumulation areas and advise on drilling points. Simply put, oil and gas seismic exploration is like a CT scan of the Earth's surface. What are the challenges of seismic exploration? As seismic exploration goes deeper, geological conditions are increasingly complex. This means oil and gas companies require more advanced exploration technologies. The most widely used are high-density wide-azimuth wideband technology, high-efficiency acquisition technology, and high-precision seismic imaging technology. However, these technologies are leading to computing power shortages and higher storage requirements. In addition, the equipment used at different data centers was deployed in different phases, causing limitations on system scalability and preventing the system from effectively processing mass data. Here are some examples. Different imaging algorithms such as PSTM, WEM, PSDM, and RTM differ in terms of map quality and compute resources. The CPU compute time required by PSDM is 2.5 to 3 times longer than that needed by PSTM. The compute time required by RTM is 7 to 10 times longer than that needed by WEM. Even when using the same algorithm with different parameter settings, the compute time required to generate tectonic maps varies greatly from VTI-PSTM and TTI-PSTM to ORT-RTM, potentially taking between 3 and 15 times longer. Today, high-density wide-azimuth wideband acquisition technology produces clearer maps than common technologies. The new technology has become a main trend among oil and gas exploration technologies, but also poses new challenges to computing and storage. Here are a few examples of tender projects we participated in from 2019 to 2020. As you can see from the last column in the table, mass data needs to flow through dozens of modules for processing, which can require 10 to 15 times more storage than the raw data. In 2020, a data center hosted 45 projects where the raw data volume was 1,616 terabytes, but the required storage capacity was 24 petabytes. Another center hosted 35 projects with 1,605 terabytes of raw data, but 24 petabytes of required storage capacity. Some other data center has added 32, 43, and 74 petabytes of storage in 2018, 2019, and 2020, respectively. How is Huawei dealing with these new challenges? First, Huawei provides high-performance, professional storage that offers high bandwidth, concurrency, and capacity. This storage has 5 key advantages: scalable architecture, dedicated hardware, efficient algorithms, open solutions, and an optimal business model. Second, Huawei adopts highly scalable storage with elastic architecture and symmetric interconnections for on-demand expansion and use. Performance grows linearly as capacity can be expanded on demand in just minutes. Huawei's unique InfoTurbo technology uses the intelligent prefetching algorithm to implement zero-copy design on the I/O path. Multiple technologies such as SMB multi-channel are applied to large file reads-writes. Third, Huawei adopts easy-to-manage intelligent storage that offers simplified configuration, supporting intelligent O&M, optimization, and management. Huawei manages storage systems at 3 layers: device layer, data center layer, and off and on-premises cloud. These 3 layers are integrated to achieve efficient O&M. At the device layer, Device Manager enables intelligent management and simplified O&M. At the data center layer, Huawei Ocean Store DJ software is used to manage the entire lifecycle of data center storage. At the off and on-premises layer, Huawei e-service software automatically reports device information to the cloud. The cloud then uses online training to provide intelligent decision-making suggestions and pushes them to local devices, implementing AI collaboration both on and off-premises. Seismic data processing heavily relies on bandwidth and concurrency. Typical requirements are as follows. The computing power of a single node must be greater than 1 teraflops. The read-write bandwidth must be greater than 1 gigabyte per second. A maximum of 20,000 instances can be concurrently processed. The latency must be between 200 and 400 microseconds. Huawei's typical solution meets all of these requirements. The solution consists of 3 parts: computing, switching, and storage, including online and backup archiving. Huawei's typical solution has 128 nodes and 1 petabyte of storage. It features high bandwidth, high concurrency, high reliability, easy management, and flexible scalability, offering computing power that reaches 149 teraflops. The read bandwidth reaches 33.9 gigabytes per second. The write bandwidth reaches 35.1 gigabytes per second, and the latency ranges from 200 to 400 microseconds. It can also be scaled to 4,096 nodes. Therefore, Huawei's high-performance NAS storage solution for full-stack mass data processing can fully meet the requirements of oil and gas exploration. In addition, Huawei's next-gen Ocean Store Pacific uses an ultra-high density design to condense multiple cabinets into one, lowering TCO. Ocean Store Pacific provides multi-protocol interworking capabilities for zero copy throughout the entire process, improving process and storage efficiency. Ocean Store Pacific also provides a hybrid load design. One storage system can meet needs in different phases. How do we use this solution? Let's take a look at some specific application scenarios. For example, 3 storage nodes, 8 compute nodes, and 16 threads are deployed in this scenario. The bandwidth of each storage node reaches 2 GB per second, which can meet the requirements for seismic data processing. We know that QPSDM has better imaging performance than KPSDM, but requires more compute time and higher storage performance. In this example, we use 644 terabyte NAS disk arrays and Huawei 1 petabyte parallel storage to run the compute-intensive algorithm QPSDM. As shown in this figure, Huawei parallel storage CPUs provide much higher operational efficiency. This is an example of PSTM. We know that PSTM has better imaging results and has become a routine process. However, it requires very long compute time and typically uses CPU plus GPU heterogeneous computing, which requires high storage concurrency. On the left is one brand of storage. On the right is Huawei's parallel storage. We can compare these two brands' efficiency when running PSTM. The monitoring software shows that running efficiency is vastly improved with Huawei storage. Huawei's high-performance parallel file system significantly improves the concurrent processing of mass data. The figure above shows the read and write bandwidth of 6 petabyte Ocean Store 9000 while running 1,000 seismic processing jobs. We can see that the bandwidth can reach 13 to 14 gigabytes per second. The figure below shows 500 concurrent processes on the storage system handling reads and writes and multi-user interaction. CPU monitoring data shows that the CPU usage reaches 60%. Huawei provides customers with more solutions and flexible business models to build private clouds and on-premises clouds. This is a Huawei cloud computing platform built for a large oil field in China. The platform uses 12 petabyte Huawei storage to provide the oil field with data processing and interpretation services. The oil and gas industry has undergone sweeping changes, resulting in new challenges such as mass data processing, high-precision reservoir modeling, data governance, collaborative research, and independent workflows. The development of next-gen IT and digital technologies have led to requirements for the application of high-precision geophysical algorithms, superb computing power, high-performance storage, and powerful AI. Therefore, customers in this industry need to improve quality and efficiency, centralize IT infrastructure resources, and accelerate enterprise migration to the cloud to reduce the amount of investment required. The IoT, 5G, cognitive computing, and AI will facilitate the digital transformation of oil and gas exploration while accelerating the development of digital basins and smart oil fields. That's all from me. Thank you.
Great topic from Mr. Lai. Thank you very much.